Welcome back. We're going to look at using the sign analysis method to solve a rational inequality. And with this example, unlike the previous examples, I want you to notice that the inequality at this moment is being compared to a number that's not zero. So this is going to involve a little bit more work, still doable on this part, but we need to use our algebra skills to rewrite this inequality so that we can set it up so that we can use the sign analysis method. So the first thing I'd like to do to start this off is I'm going to rewrite the inequality so that everything's on one side and zero's on the other. So what that means is you're moving the 3 over. Well, I guess there's more than one way to go, but I think it's a little nicer to subtract 3 from both sides. So when we rewrite it, you're going to still have your x minus 8 over x minus 4. But when you move the 3 over, you're subtracting 3 from both sides. So that gives you an inequality expression that's now compared to 0. And that's what we'd like. Now, before we can actually use the sign analysis method, there's one more thing to do. We're going to refresh our algebra skills. And the idea is we're going to need to combine this part over a common denominator. So I'll write that down. So we have to reach into our past and remember, in order for us to combine over a common denominator, we're going to need to find the common denominator first. So if you notice that I see a denominator of x minus 4, but when I'm looking at the 3, if I were to think about it, if I were to write it as a fraction, right now its denominator is just a 1. So with this type of problem, it might be good just to kind of think about that the LCD is actually equal to x minus 4. So remember, with inequalities, we're not allowed to multiply through to clear out any fractions. There's an issue with the inequality symbol. We're not knowing which direction it should face, depending on what sign of the denominator or the LCD we would have. And because we have an x, we're not clear whether or not that x is going to give us a positive or negative denominator because we don't know what the value of x is. So what we're looking at is, if you know the LCD, you're going to just try to rewrite each fraction into an equivalent fraction such that the LCD is the denominator. So if I am looking at the x minus 8 over x minus 4, you guys notice that already has the LCD. So I'm going to just keep it the same. And with the 3 over 1, what has to happen, and I'll write this over again just so that you can see, we're going to need to turn the 1 into an x minus 4. So what that means, we would multiply the denominator by x minus 4 as well as the numerator, so that we are still building to a higher term. So we still need an equivalent fraction. That's why whatever you do to the denominator, you do to the numerator. And remember, the inequality is still compared to 0. So really, the majority of the work for this type of problem is involved with making sure you're going through the algebraic steps to simplify this left-hand side expression into a single fraction. So let's proceed. Still have the x minus 8 over x minus 4. And then you'll notice that we now have the x minus 4 in the denominator. 1 times x minus 4 is x minus 4. And there's more than one way to do this. I'm going to take it slower just in case. I know there's some shortcuts we could invoke here. But keep in mind that you're distributing the 3 to both the x and the 4. And if that is the case, we should have 3x minus 12 in our new numerator, still compared to 0. And at this stage, we double check. we now have the same denominator. And when that is the case, when we are simplifying this expression, we now can combine. So we're going to rewrite everyone so it's over the common denominator of x minus 4. And again, I'm taking it a little bit slower so you can see it. But when you are now doing this, you are actually subtracting the numerators. So keep in mind, when you are subtracting more than one term, you need to enclose that inside parentheses. So this is where you see the red, the 3x minus 12 inside. Still compared to 0. So now we actually have a single fraction being compared to 0, but in order for us to kind of find the boundary points, the work now relies on you being able to simplify the numerator. So in order to simplify this numerator, the first thing we would do for ourselves is try to distribute to get rid of the parentheses. So we're kind of distributing this negative sign. So that is going to leave us with negative 3x plus 12. And still, I had the x minus 8 in front, and I still had the x minus 4 in the denominator, still compared to 0 as less than 0. So once we distribute to get rid of the parentheses, now it's a matter of combining like terms. So we see we have x terms and we have constant terms. So I'm going to take a little time on that and say, okay, x take away 3x is going to leave me with negative 2x. And negative 8 plus 12 should leave me with a positive 4 or plus 4. So now I have negative 2x plus 4 still all over x minus 4 compared to 0, less than 0. And this is the stage we want to be in so that we can use the sign analysis method. So notice, just so that you can kind of see, we now have a single fraction and it's compared to 0. That's the comparison with the inequality symbol, and I know you know 0 is 0. So now we're ready to start with the sign analysis method. The first thing you want to do is find the boundary points. So I'll kind of go up here to help you out a little bit. So first things first, let's find those boundary points, and I'm going to scroll up. Let me rewrite it for you now that you see it. So we have negative 2x plus 4 over x minus 4 less than 0. And when you're looking at rational inequalities, when you are going to find the boundary points, as long as they are being compared to 0, the boundary points are found by setting the numerator, which is negative 2x plus 4. We're going to set it equal to 0 and solve that equation. And I'll kind of use a colon here. There we go. So when we solve, I'll subtract the 4 on both sides. So I have negative 2x equals negative 4. And dividing both sides by negative 2, we should get x equals positive 2. So there's one boundary point to look at. And we'll also take care of the denominator. So same idea. We'll set this denominator equal to 0 and solve for x. So that's going to give us x equals positive 4. So that's the idea in terms of where we're trying to figure out where we're splitting up the number line. Keep in mind, if you run into a little bit more difficult expressions in the numerator or denominator, sometimes you may have to solve quadratic equations, but you have the skills, so I have my faith in you. But with these boundary points, now that we have this, it's kind of almost the same thing as what we did in chapter 3. So what we're looking at, we'll plot our boundary points in relation to each other on the number line. So I believe 2 comes before 4. And those boundary points break the number line up into, in this case, 3 different regions. And in this point, we're going to look back at our inequality and we're going to notice like this was just nice linear factors in this inequality. So we will list all of our factors in the numerator and factors in the denominator off to the left side. So negative 2x plus 4 and x minus 4. This is further going to split up the test regions into now 6 different regions. So you're starting to realize, oh, it's very much like what we did in chapter 3, except we're starting off with a different function. So now we'll take the time and we'll use test points in each region. So I'm looking at the region that comes before 2. And then again, we might take a little more practice on this, but if you need to, feel free to write it out just so that you see that you're testing x equals, I see a number that comes before 2, I'm gonna say 0. And what you're doing is you're plugging it into each of the factors. So that becomes negative 2 times 0 plus 4. And then when we actually simplify, we end up getting a positive 4, and all we care about is that it's positive. So that's where we're plotting the sine. Now, if you're able to do this mentally at this point, feel free. You don't have to write the working on the side. But I always find it nice when I'm giving an explanation so that you could have something to refer back to, just in case. So we'll also plug in 0 to the factor. 0 minus 4 is going to give us a negative. So we have this going on. In the middle, between 2 and 4, I know we can pick any number, but I would like to pick, I like integers, so I'm going to go with 3. And if I do that, I have negative 2 times 3 plus 4. So that's going to give me negative 6 plus 4, which is going to give me a negative. So that's where I'll plot it. And now I have 3 minus 4. So that gives me also a negative. I'll plot that again. Then one more region to test in a sense. Something that comes after 4, 5 or 6, however you'd like. Even 10, something bigger if you'd like. So I'll go with x equals 6 or so. And so if I'm plugging this into the factor, I have negative 2 times 6 plus 4. So that's giving me negative 12 plus 4. Negative 12 plus 4 is negative. Then we have 6 minus 4. And 6 minus 4 is positive 2. So we have a positive sign we'll plot. So now that we have all the signs graphed or plotted, you're going to think about what you really did with these factors. And as a shortcut, we always say just multiply the signs vertically, mainly because multiplication and division take the same rules. So if you notice, you're really taking negative 2x plus 4 and dividing it by x minus 4. So if you were saying positive divided by negative, you're still going to get a negative region. But to kind of, I guess people like to think in multiplication before they like to think in division. So multiplying the signs vertically will still give you the same result. So I'll take it that way. So just as we said, negative divided by negative is positive. Negative times negative is also positive. So we can go that route. Negative divided by positive is negative. Now we have our signs of the regions. The last thing we're going to go back and look at what direction the inequality was facing when compared to 0. And so this is after we did all the work so that we could rewrite it as a single fraction compared to 0. So again, I'm referring back to this inequality. And notice when we say less than 0, we're basically asking the question, where do we see a negative region? So we're going to go back and view our signs, and we notice, yeah, we actually have a negative region on the left and on the right. So now, if you're ready, we'll take our inequality and write our solutions. So if I'm going to describe the regions that I have, if I'm looking at the far region on the left, I have negative infinity to positive 2. Okay, so let's talk about that. Negative infinity to positive 2. And notice the inequality symbol is strictly less than, so we don't have to worry about issues with brackets or whether or not to use the brackets. We're always going to use parentheses. We have a jump, so we're going to go with a union, and then start up again at 4 to infinity. Sorry about that. Hope you didn't get dizzy. And now we have the solution to example 3. Now, as a side note, I would like to emphasize the reason why we spend a lot of time with the sine analysis is that it allows you to solve 2 problems for the price of 1. So I have a what if question for you, and you probably guessed it because I've asked this with problems in quadratic inequalities or polynomial inequalities. But I want to ask you, what if the problem, instead of the inequality being less than 0, what if it was facing the other way? So the question is, what if we wanted to solve and we'll look at the original inequality one more time. It was x minus 8 over x minus 4. So x minus 8 over x minus 4. But what if we wanted to solve where it was greater than 3? Well, we've already taken the time to rewrite the inequality symbol compared to 0. So the work is still the same. Nothing has changed in this sense. So you don't have to rewrite all of the work we did over here. We've actually demonstrated it. We do know that the original inequality is equivalent to the inequality we rewrote when we were trying to make it compared to 0. So we could go straight to rewriting this as negative 2x plus 4 over x minus 4, instead of instead of less than 0, we're going to have this rewritten as greater than 0. So nothing's changed except for the direction the inequality symbol is facing. So now, if you're trying to understand, what does that mean? Remember, greater than 0 is asking you to figure out where do you have the positive regions. So if you're going to answer that question, you could kind of see, oh, it's the opposite of what we colored in yellow. It's actually all the numbers between 2 and 4. So here, you can solve 2 problems for the price of 1 just by creating the sine graph. So this is going to come in handy. You're going to see some examples later in the section where they want you to solve the equation and related inequalities. So we're going to build on this. So I'll see you then.